Hey guys, welcome to the demo video of our project PolliSync. So before we begin, let me give you a quick sneak peek of what our project actually is. So whenever we talk about agriculture, most people focus either on crop yield, harvesting techniques, or how to keep the crops fresh after the harvest. But has anyone really paid attention to the very beginning of this process? Yes, I'm talking about pollination. So I do not come from a biology background, but as we all know, that pollination is one of the most important processes for any plant or crop. It can happen naturally as well as artificially, but farmers often have limited information to tell them when the conditions are actually suitable for successful pollination. So, what if? What if, based on the farmer's current location and crop type, we could provide a pollination suitability index? Yes, you heard that right. A PSI score that would help the farmer make smarter and more well informed decisions related to their farms. With that introduction, let us begin with our demonstration. First, I'll be logging into our application. So I've already logged in, but for new users, we have a three-step onboarding process. What is this three-step onboarding process, you ask? Firstly, the user will enter the farm name along with its location using an interactive map. Then they will select the crop type from the 5 supported crops. And finally, they would enter farm details such as its area, soil type, and the planting date. Once that's done, we arrive at our dashboard as you can see here. So something feels off. Oh, let me turn on the dark mode. I personally prefer that. Yes, now it looks really good. So at the very top, you'll see a pollination suitability index or a PSI score, which is generated using our very own machine learning model. We've trained this model using trusted open source datasets and real-time weather data from NASA Power. It generates a score out of 100 along with low, medium, and high risk labels. What do these tell us? The higher the PSI score, the lower will be the risk of pollination failure. Using real-time API calls, we fetch environmental features from Open-Meteo for weather, NASA Power for 7-day environmental features, and GBIF for actual pollinator sightings. We fetch all these information, our backend processes it, feeds it into our machine learning model, and it generates the final PSI score that you can see on the screen. Below the PSI score, you can see the current microclimate cards for temperature, humidity, rainfall, and wind data in real time. But this data on its own does not provide much information to the farmer. So that's where our AI agronomist recommendation system kicks in. It is a specialized AI assistant powered by Gemini that provides personalized recommendation. It fetches all the environmental features that are shown here and suggest best practices to the farmer, such as how to maintain better crop health or improve pollination conditions. So instead of just showing numbers on the screen, it explains the reason behind those numbers, making the data more easy to understand and act upon for the farmers.